Hello everyone. In this video I will go over section 2.3. So section 2.3 is solving right triangles. So in this section you're going to put many of the last sections together into one. But first let's be clear, what does it mean to solve a right triangle? So you have a right triangle. A right triangle, notice that it has 6 pieces of information. So it has side A, side B, and the hypotenuse, but it also has 3 angles, which we call this theta, which can call this beta, and then obviously you have the 90-degree angle. So of the 6 pieces of information, 1, 2, 3, 4, 5 are the ones that you may need to find. So when it says to solve a right triangle, this means to find theta and beta, and also means to find A, B, and C. Now, you already know how to find all these things depending on how the problem looks or what information they give you. So therefore, if they give you A and B, you can find C. If they give you B and C, you can find A, and so forth, using the Pythagorean theorem. So you can use the Pythagorean theorem usually to do this. But you can also use trigonometry, and it all depends on how the question is asked or what information you are given. Also, notice, in case you haven't noticed this, that for a right triangle, theta plus beta always has to be equals to 90 degrees. So for example, so let me do here a illustration. So if you have a triangle, right triangle, we're only talking about right triangles, and let's say that they already give you the size, and this is 3, this is 4, and this is 5. So if they tell you that this is 40 degrees, and they ask you to find this one, so let's say this one is beta, well, so therefore this automatically implies that beta has to be 50 degrees. Why? Because if this is 40, this one has to be 50 to add to 80 to 90. The whole angle, the value of the 3 angles inside is equals to 180, but this one is always gonna be fixed to 90. So that means that alpha plus beta, or theta plus beta, is gonna be 90 degrees all the time. Also, the other thing that is gonna be used a lot, if you have the size already, so for example here, let's say do another illustration here, and then we'll do full problems in a little bit. Let's say that you have this problem, which we already know the answer to this, but let's pretend that we don't know. Let's say that this is 1, this is 2, and this is already equal to 3. But let's suppose that we don't know what the angles are. So let's call this theta and this beta. Okay? So this is one of the special triangles, but let's say that you did not know that. So this is the given information, this, and this. The only thing missing are alpha and beta. So therefore, there are multiple ways to do this. For example, if you want to find theta, you can use sine, you can use tangent. So let's say that we use sine. So therefore, sine of theta is going to be equals to 1/2. But the thing that you want is theta. So how do you figure out theta? You can use a calculator, and to find theta in the calculator, there is a key called sine inverse. So you do sine inverse of 1/2, and you should check that it gives you 30 degrees. You need to make sure though that this is in degrees and radians for the calculator. okay? Or you could have done tangent of theta, it will be 1 over radical 3. So tangent of theta will be this over this, which means that theta will be tangent inverse of 1 over radical 3. And you can check using the calculator again that this will also be 30 degrees. All right, so this is what we're going to do right now, okay? So if they give you the size and you need to find just an angle, you're going to use either sine inverse, tangent inverse, cosine inverse, or so forth. If they give you the size, two sides and one side is missing, you're going to use the Pythagorean theorem. So this is essentially what we have done in the previous sections. And so this is just a few steps farther. But the key point to remember here is if the question is asking you to solve a right triangle, only means find the missing sides and the missing angles given the information. All right, so let's start with a problem that we have done a few times. So let's say that this is obviously a triangle. So you have triangle ABC. And let's say that the given information is this, that A is 5, B is 12, and C is 13. Okay, so they give you that already. So you already know that A is 5, B is 12, and C is 13. So let's say this is already given. And you want to figure out what theta and what beta are. Okay, so therefore here let's focus on theta first. So again, you can use tangent or you can use sine. So let's use tangent. So tangent of theta by definition, remember, is the opposite over the adjacent. So this should be 5 over 12. So then theta is going to be now tangent inverse of 5 over 12. And for this, you need the calculator. In the calculator, to access, you have a TI, so you have a TI 84. To access this, you have to first click the second key. Make sure that the calculator is in degree mode, second key, and then just literally click tangent and then enter 5/12. So therefore you do that in the calculator. This gives you 22.62 degrees. Now to find the other angle, you can use the same method for beta, or you can use the fact that this angle plus this one has to add to 90. But let's do it both ways to check that the answer is the same. So let's say you need to find now beta. Okay, so therefore let's use now, I don't know, sine. So notice the sine of beta will be 12 over 13. Why? Because the opposite of beta is 12 and the hypotenuse is 13. So therefore from here, beta is going to be sine inverse of 12 over 13. And again, using the calculator, it's going to be the same keys. You have a TI 83 or 84 second, and then you just click, in this case, sine, and then 12 over 13, and the answer is 67.38. Now notice that this plus that is clearly 90 degrees, okay? All right, so note, I just told you this right now. Theta plus beta has to be equals to 90 degrees. So the other way you could solve the problem, once you find this, well, just plug it in here, and you know that 22.62 62 plus beta has to be 90 degrees. So if you solve for beta, then beta will be equals to 67.38. So the point is that once you find one angle, since these two had to add to 90, there is no way to do it both ways. You should try both ways anyway, so you can just check your answers and so you get more practice. So now for this particular problem, now the triangle is solved because you already have the three sides and you have the three angles. All right, so let's do a slightly different version of the problem. So again, you have triangle ABC, but now let's say that the information given is this. Let's say that theta is 37 degrees, and let's say that A is 5, and let's say C is 8.3. Okay, so this is the given information. So I highly recommend you to do a triangle right away. So the information you have: A is 5.0, let's say that. C, the hypotenuse, is equals to 8.3, and then theta is equals to 37 degrees. Okay, so here the part that is missing is B and also beta. Okay, so you're missing one side and one angle. All right, so in this case, the easiest way to find the missing part is to use the Pythagorean term. So therefore, if we do that, remember that BA squared plus B squared should be equals to C squared. So this is the Pythagorean term, okay, which we have used many times now. So notice that this is 25 plus B squared is equals to 69.02, something like that. So then B squared will be 69.02 minus 25, which means B squared is equal to 44.02. So then B is the square root of this, which is approximately equals to 6.6. So therefore now you know what this is. So this is 6.6. So now the only thing missing is the angle beta. So remember that theta plus beta has to be 90 degrees. So that implies that beta will be 90 degrees minus theta, but theta was equals to 37 degrees, so this is equals to 57 degrees. And there you go, that solves the whole right triangle. Now notice, and this is going to be important later because we're going to do this multiple times later. So note the following. Okay. So let's say that from the very start, if you pay attention, let's say you want to find a sine of theta or cosine of theta or cosine of theta. So you want to find cosine of 37 degrees, which could have been this. And at that point, we didn't know what B was. So let's say you wanted to find this without using the Pythagorean theorem, which that's probably the easiest way. But sometimes, let's say this side was also missing. So this was not here. And this is all you have. So then, if this was the case, notice that cosine of 37, it would have been this over this. Okay, but because this was given. So therefore, cosine of 37 would have been B over 8.3. So if you solve for B, you cross multiply. B will be 8.3 times cosine of 37 degrees. And you can check that this would be exactly 6.6 again. Okay, so that will be another way to find that. And we'll do an example in a little bit where you have to do this no matter what. For example, look, let's say we have this problem. So this is the information you are given. They only tell you this is 25, but now you're missing two sides. Okay, so let's say this is A, this is B, and obviously this is C. Okay, so if this is the case, you can use either sine, because it's this over this, or tangent to figure out B. Once you figure out one side, you can find the other side. But let's go with tangent. So let's say tangent of 25 degrees. This will be 4 over B. Okay. Then you use a calculator and first cross multiply, and then from here you're gonna have that B times tangent of 25 degrees should be equals to 4. You cross multiply, which means that B will be 4 over tangent of 25 degrees. So in this case, this is around 8.578, which if you round to two places, this will be 8.6. Now it should be obvious that beta, which is missing, the beta should be 65 degrees. Why? Because these two angles must add to 90 degrees. Now from here, once you know that this is equals to 8.6, then you can use the Pythagorean theorem to find C. But let's use this same method to figure out what C is. You could also have used sine, let's say sine of 25, and notice the sine of 25 is the opposite of the hypotenuse, so this should be 4 over C. And if we use the exact same technique we did here, notice the C is going to be 4 divided by sine of 25 degrees. So 4 divided by sine of 25, it will be 9.464, which if you round it to places, it will be 9.5. And there you go. This solves the whole triangle. So you have the three sides now and the two angles. Now lastly, I'm gonna do a classic problem that it looks very complicated because you had to do like two problems in one, but it's not that bad. But this is a classic problem that you will see everywhere. So the problem is usually like this. Let's say you have first a big triangle like this. Obviously it has to be a right triangle, okay? And then you have a smaller triangle inside, like that. It could be like this, okay? And you have two angles here. They will give you two angles. Let's say that this one is, for example, 37 degrees, and this is 52 degrees. And this, you don't know what it is, and they tell you the distance from here to here, let's say is 100, and the distance between here and here, from here to here, is x. And the question is technically, what is x, okay? Now this is a little more complicated because you don't know what h is and you don't know what x is. But let's focus here on the first triangle, because you have technically two triangles. You have first the green one, which will be this part, this triangle, and then you have the white one, which I will call this one. But notice that both of them have the exact same height, so that's the key to the problem. So we focus on the green part first. Notice that if we do tangent of 52 degrees. So tangent, it will be h. This is the opposite, and the adjacent is x. So this should be just h over x. Okay? So notice that from here, h will be equals to x times tangent 52. And you cannot solve this problem yet because you don't know x and you don't know h, but you know this part so far. Okay? So then the next part is you have a bigger triangle, which will be this. Okay? So for that one, you have now a different angle. You have tangent of 37 degrees, and it will be now h over all of this is now 100 plus x. And again, if you solve for h again, notice that this time this will be 100 plus x times tangent of 37. Now, this is the next part you need to notice. Here you have an equation for h, and here you also have an equation for h. Since the h is the same for both triangles, that means that this and this has to be the same. So therefore, this means that x tangent of 52 degrees is going to be equals to 100 times tangent of 37. I'm going to distribute this plus x times tangent of 37 degrees. Now, the only reason why I distribute is because you have x here and you have x there. So notice if you have like 3x plus 5 equals to 8x, what you usually do, you will move the x to, if that was the case, let's say this was the x, I forget to put x there. So you wanted to solve for x, you will have to move this to this side. So that's exactly what we're doing. So we're just going to factor the x. So we put x, and you have tangent of 52 degrees. If you move this one to the other side, notice that when you move it to the other side, it changes the sign. So it's going to be minus tangent of 37. And all of this should equal to 100 tangent of 37 degrees. So therefore, you want to solve for x. You just divide both sides by this part, by this. So divide by this, both sides. And you end with this. Divided by tangent of 52 minus tangent of 37 degrees. And then just use the calculator to figure this out. So you use the calculator, this will give you 143.15. So therefore this is around 143.2. You run to two places. So then if you want to find the solution, you can just plug it in here. So the altitude, it will be x, which is 143.2 times tangent of 52. So times tangent of 52 degrees, and that equals to tangent of 52, 183.23. And that's it.